Today we're going to summarize all three forms of a quadratic and talk about which form of a quadratic to use when. So we could just call this which form of a quadratic. So let's review our three forms. We have vertex form, which was y equals a, x minus h squared plus k. We have standard form, y equals ax squared plus bx plus c. And then we have intercept form, which was y equals a, x minus q, x minus p. And we spent a couple days going back and forth for these. So now we're going to talk about, when do we want to use some of these? So for example, if I asked you to find the min or the max of the parabola, which would be the easiest form to do that? You can find it in all of these because we've talked about going back and forth, but the min or the max is that y value, and it would be easiest to find that in vertex form. Maybe I'll start putting some of these in some boxes here to keep organized. Let's say you wanted to find the intervals where it is increasing or decreasing. So again, if you look at a parabola, either a happy one or a sad one, it's increasing when that slope is going up. So that would be our increase. And then it's decreasing when, again, you're reading this like a book when it's going down. So what form would be the easiest to find that interval would be, once again, vertex, because that's where it changes at the vertex. What if I said the y-intercept? Now remembering our y-intercept is just 0, some y value. So any of them would be really easy to find the y-intercept because you just plug in x for 0, but it'd be really easy in standard form because you have a times 0 squared plus b times 0 plus c, which that just reduces down to c. So standard form would be really easy to find that. X-intercepts. Well, that should be really easy to find the x-intercepts. You're going to want intercept form. That would be the easiest to find those. And then one thing that we haven't talked about here is when is it positive or negative? And this has to do, it's positive if it's above the x-axis. It's negative if it's below the x-axis. Oh, I spelled that wrong. So if you're talking about above or below the x-axis, let's say we have this one right here. It's positive right here. But if we had this again, it's negative when it's under there. So the easiest to find that is going to be intercept form. So we're going to take a look at a couple of these here and see if we can figure out when to use it. So what your assignment here, I want to make sure we're kind of clear with this. Let's see, hopefully you can see this here. A quadratic is hidden from view. You must find the minimum value of the function. Choose the form you want. So we're looking for here the minimum. We can see right here. Choose the form we want, and we could select these forms. And again, you could find it in any of them, but the minimum would be that vertex there. And so what is our vertex? Positive 2, negative 32. And our minimum is just that y value. So it's negative 32. So the key on all of these is to see what you're looking for. This one is looking for the maximum. So what form do we want for that? We could go to vertex form. And then again, our maximum is just our y value of 2. Some of these might take a little bit more practice. For this one, you must find all the intervals where it's positive. So we said positive is when it's above the x-axis. So if we go into factored form, we know if we were to sketch this, and this is going to help, it's going to cross at positive 3, 0, because it's x minus 3, and negative 1, 0. So when is this positive? Well, it's positive when it's above the x-axis. So those two right there. So we could say when x is less than negative 1, union when x is greater than 3, because it's both of those intervals there. And then we can submit that. And I think this is how you submit it. Let's take a look and see what it says. Nope. So this one. Oh, and see, this is where it's nice to use your answers. What did I do wrong? It was a negative parabola, so it should have been facing down, so it was in between those two values. So that's a good thing to catch, that we need to make sure that we're saying whether it's a positive or negative. Let's see if we can find another one like this. Find all intervals where it's positive. So we'll do that factored form again. And let's see if we can get this drawn correctly here. Whoops. So, where is this one crossing? So it's crossing at negative 6, 1, 2, 3, 4, 5, 6. Positive 8, 1, 2, 3, 4, 5, 6, 7, 8. Because again, it's the opposite of plus 6 and minus 8. So where is it positive? And you can see I made that parabola upside down because we know it's a negative one. Whoops. So it's positive in between those values. So we can go negative 6 is less than, x is less than 8. And we can submit that answer. So there's another maximum value, trying to find a bunch of different ones here. So here is one where it asks to find the y-intercept. And again, we talked about how the y-intercept could be any of these, but it's really easy to do in standard form. So our y-intercept, when we plug in 0, so 0 squared minus 4 times 0 plus 12. So there's one y-intercept, so that would be the coordinate 0, 12. If we can get one more, I want to see if we can find an increasing one here. Here's one last one. You must find all intervals where it's increasing. So again, a nice easy way to see what this parabola looks like is to go to vertex form. So if we were to make a sketch of this one, it's increasing, or it's vertex, excuse me, positive 3 and negative 2. And what do we know? We know that's a positive 2 out in front, so this is a happy one. So it's increasing when it's like its slope is going up. So if you were to draw this parabola left to right, when is your pen going up? So it's increasing to the right of the vertex. So we'd say when x is greater than 3. So why don't you go to your Delta Math and try this assignment?